Imagine traveling back to the very beginning of the universe, almost 13.8 billion years ago, when the very first stars were just beginning to form. Many people would assume that the stars then would shine for the same reasons as they do now. But there's a possibility that some of the very first stars may have not shined because of nuclear fusion. Instead, they may have been powered by one of the greatest mysteries in all of physics, dark matter. These strange objects are known as dark stars, and although we've never confirmed one exists, some astronomers think that the James Webb Space Telescope may have already found a few candidates. So, what exactly are dark stars? To understand dark stars, we first need to talk about dark matter. Everything you've ever seen, every planet, every star, every galaxy, even you, is made from ordinary matter. But, surprisingly, ordinary matter only makes up about 15% of all matter in the universe. The remaining 85% is something we call dark matter. We can't see it. It doesn't emit light, it doesn't reflect light, it doesn't absorb light. In fact, the only way we really know it exists is because of gravity. Without dark matter, galaxies wouldn't stay together the way we observe them today. So, although it's invisible, dark matter acts like an enormous cosmic scaffold, holding galaxies together. But scientists wondered something else. What if dark matter doesn't only have gravity? What if dark matter particles can occasionally collide with each other and annihilate? If they can, they'd release enormous amounts of energy, and that's where dark stars come in. Normally, stars form when giant clouds of hydrogen collapse under gravity. As they shrink, the pressure and temperature in the center rise until the hydrogen atoms fuse into helium. That's what powers every normal star, including our sun. But conditions in the early universe may have been different. The first clouds of hydrogen were forming inside halos filled with dark matter. If enough dark matter collected in the center alongside the gas, and if those dark matter particles annihilated, they would release heat, lots of it. Instead of collapsing rapidly into a normal star, the cloud would become warm enough that gravity could no longer squeeze it any tighter. Fusion would be delayed for millions of years. Instead, dark matter annihilation would become the star's primary power source. Ironically, a dark star is actually made almost entirely of hydrogen and helium. Dark matter makes up less than 1/10 of 1% of its mass. Yet, that tiny amount could completely change how the star behaves. Without fusion forcing the star into the compact shape we're familiar with, dark stars would remain incredibly large and puffy. Some models suggest that they could stretch across hundreds of astronomical units. For comparison, Earth orbits the Sun at 1 astronomical unit. Some dark stars could have been larger than our entire solar system. Despite their enormous size, their surface temperatures would have only been around 10,000 Kelvin. Hot, but much cooler than you would expect for objects this massive. Because they've stayed relatively cool, they wouldn't blast away the surrounding gas like normal massive stars do. Instead, they would continue swallowing more and more material, growing and growing, until they've reached hundreds of thousands, or even millions of times the mass of our sun. Eventually, the dark matter fueling them would run out. Without that energy source, gravity would finally win. The dark star would collapse. Some astronomers think that this collapse could have formed some of the supermassive black holes we see surprisingly early in the universe. For many years, dark stars remained purely theoretical. But in 2023, everything changed. The James Webb Space Telescope discovered several incredibly distant, incredibly bright objects in the universe's earliest era. Most astronomers interpreted these as very early galaxies. However, another research team proposed a fascinating alternative. 3 of these objects match predictions for supermassive dark stars. If that's true, these stars would each contain between roughly 500,000 and 1 million times the mass of our sun, while shining with the light of billions of suns. At the moment, these are only candidates. The observations aren't detailed enough to tell whether they're actually dark stars or simply distant galaxies. Future observations will be needed before we know for sure. Dark stars may have never existed. Some computer simulations suggest that interactions during the formation of the first stars could have prevented dark matter from collecting efficiently enough to power them. Other studies still find them possible. Right now, scientists simply don't know, and that's what makes this idea so exciting. If dark stars are ever confirmed, they wouldn't just reveal a new type of star. They would provide our first glimpse into how dark matter behaves. They may explain how supermassive black holes form so quickly after the Big Bang. And they could completely reshape our understanding of the first chapter in the history of our universe. Until then, Somewhere in the deepest reaches of space, the universe may be hiding stars that never burned with fusion at all, but instead were powered by one of the greatest mysteries in modern science.